Okay, this video is going to get us started onto our review of probability. Um, there are a lot of different kinds of probability questions, and so we're just going to focus on the types of questions that we learned in chapters 2 and in chapter 7. So these are going to all involve z-scores. These would be, I think, on the easier side of probability questions. So I'm going to hope that the AP test has something on there with z-scores. So here's what you need to be most careful about. How many people are in the sample, or how many things are in the sample. If it is just an individual, it's just a straight up z-score problem. Okay? You'll be given the mean, you'll be given the standard deviation, you'll be good to go. But if it is a sample of individuals, then you need to be cautious and you need to use these formulas down here. It's still going to involve a z-score, except the mean and the standard deviation, you have to do a little calculation with those first. Now, the blue box is if you're dealing with proportions. The red box is if you're dealing with means and standard deviations. It all depends on what the given information is about. The idea is that these are dealing with sampling distributions. And we have some conditions that we have to check first before we can use these. So if you are dealing with a problem involving proportions, the conditions that you need to check are, is the population more than 10 times the sample size? And is the sampling distribution approximately normal? Is n times p greater than or equal to 10? And is n times 1 minus p greater than or equal to 10? Those are things that you have to check for if it is a proportion problem. If it is a mean problem, you still have to check to see if the population is more than 10 times the sample size. And you need to check to see if the sampling distribution is approximately normal. Okay, now, if it says in the problem that the population is normal, if it's a yes, then you're good to go. If it's a no, then what you're going to do is check to see if your sample size is more than 30. If it is, then the central limit theorem is going to apply. And then you'll be good to go. So I would, hopefully if you're taking the AP test, hopefully you're writing down formulas that are important and you've got like a formula page started. I mean, you can certainly use the formula page that we've been using all year long. I mean, you have access to this. I would find that and print it out. I have it on our PowerSchool page because you also are going to want access to the z-score chart. I'll probably post that on the page where this video is as well, just so that it's even easier for you to find. But in any case, I mean, personally, if I, given the circumstances of this AP test, I would make my own formula sheet just so things are easier to find and I can be more thorough. So again, this is when you have a whole sample of individuals, more than one. All right, so we're going to go through a series of examples here. So here's the first one. We got Honeycrisp apples, we got Sweet Tango apples from an orchard at the U of M. They are normally distributed. The weights are normally distributed. Honeycrisp apples have a mean of 380 and a standard deviation of 28. Sweet Tango apples have a mean of 320 and a standard deviation of 32. And I want to know, what percentile would an apple that weighs 350 grams be in each distribution. So let's compare in Honeycrisp versus Sweet Tango. All right, now if you're talking about percentile, we can measure percentile. That would be anything on a normal curve at or below a certain value. So this ties into z-scores. If we find a z-score, we can find the percent to the left or less than that z-score, and that's your percentile. So for Honeycrisp, let's find the z-score. If we have an apple that weighs 350 grams, we will subtract the mean for a Honeycrisp, which is 380, divided by the standard deviation for a Honeycrisp, which is 28. When you type that in your calculator, you are going to get negative 1.07. For Sweet Tango, our z-score, again, would be 350 minus Sweet Tango's mean, which is 320, divided by Sweet Tango's standard deviation, which is 32. And when you do this, your z-score is going to be 0.94. Okay, now let's get the percentiles. So the percent, or the probability of having a z-score less than negative 1.07, let's go to our z-chart. Negative 1.07 would be right here, so 0.1423. So this would be in the 14.23rd percentile. So that means that 14.23% of apples weigh less than 350 grams for Honeycrisps. Okay, for Sweet Tango, we are finding the percent, or the probability, that our z-score is less than 0.94. Go to our z-chart. 0.94 would be right here. So that's 0.8264. So that means that it would be in the 82nd 64th percentile. So that means 82.64% of Sweet Tangos would be at or below 350 grams. Okay. Next one. Same idea. This is just focusing on Honeycrisps now. Again, mean 380, standard deviation 28, and the problem says a single Honeycrisp apple is selected at random. What's the probability that it weighs more than 370 grams? So I'm trying to find the probability that my value of my Honeycrisp is more than 370. That's just me stating the problem, but in symbols. Now this is a single Honeycrisp. So back to my first page, if it's an individual, it's just a straight up z-score, nothing to worry about. So I need to do my z-score work somewhere off to the side. So 370 is the value and 380 is the mean, and then the standard deviation is 28. So when you put all that in your calculator, you are going to get negative 0.36. So essentially what I am saying up here is my percent, or my probability, that my z-score is greater than what I got here for my z-score, negative 0.36. Now, what we have to remember is whenever it's a greater than, we have to do 1 minus. Because this z-chart, all of these percentiles are to the left. This little picture up here is to remind you that all of these are going to the left. So if you want to go to the right, you have to do 1 minus. And the value we're looking up was negative 0.36. So negative 0.36, yep, is right here, 0.3594. Okay, when I subtract that from 1, I get 0.6406. So that means that 64.06% is the probability that this apple weighs more than 370 grams. Okay, now we're going to change the problem up a little bit. And now we're taking 40 Honeycrisp apples, so we're taking a sample. Okay, so now this goes back to here when you're taking a sample. Now, is this problem a proportion problem or is this problem a mean problem? Well, go back here. You were given the mean and the standard deviation. It's asking about the mean weight. So there's no percents or anything at all involved. So we're going to be using these formulas in the red box. Before we get there though, we've got some conditions we have to check. So I need to check a few things. So I need to make sure, is the population greater than 10 times the sample size? Okay, well, the sample size is 40. 10 times 40 is 400. Is it safe for me to assume that there's more than 400 apples? Yeah. And we're talking in a large orchard at the U of M? Yeah. I would say that it's safe to assume more than 400 Honeycrisp apples in the large orchard. Okay, the other thing we need to check for is the sampling distribution approximately normal. And what we always want to do is look up in the paragraph, and it said that they were normally distributed. So yeah, because the population is normal. Now, if it did not say anything about it being normally distributed, we would try and see if the central limit theorem applied. And in this case, it actually would because my sample size is greater than 30. But I didn't need central limit theorem because it said up in the problem it was normally distributed. All right, now I'm good to go. Here's my formulas. Now, the mean of the sampling distribution is going to equal the population mean. And the population mean was given to us up here, it's 380 grams. So that stays the same. But the standard deviation of the sampling distribution will be the population standard deviation divided by the square root of n. The population standard deviation was given to us, that was 28. But I have to divide by the square root of the sample size, which was 40. And I'm going to get a new standard deviation now, which turns out to be 4.42719. Now I'm going to leave all of these decimal places. When we're talking about z-scores, like up here, I rounded to 2 decimal places. But for standard deviations, it's best to leave as many decimal places as you can, and then round after you've computed the z-score. So that's what I'm going to do now. I'm going to get my z-score. So I take my value of 370 minus the mean of 380 and divide by this new standard deviation, 4.42719. Do you see how these two z-scores, the tops are the same? It's the standard deviation that changed. And now this z-score is negative 2.26. So I am trying to figure out the probability that the mean weight of my sample of 40 apples is more than 370. See the comparison? Okay, this is a mean of the sample now. And that's going to correspond to the probability that my z-score is more than this z-score now, which is negative 2.26. Look at the comparison. They have different z-scores. It's greater than, so I'm going to do 1 minus. I'm going to go over to my z-chart and look up negative 2.26. So negative 2.26 would be right here, which is which is 0.0119. Subtract that from 1 and we get 0.9881. So 98.81% is the probability that the mean weight of these 40 Honeycrisp apples is more than 370 grams. Okay. What range of weights represents the middle 50% of Honeycrisp apples at this orchard? Okay, middle 50%. So a picture might be helpful here. Middle 50%, not a perfect drawing, but you get that general idea. It's asking for what are these weights? Between what range of weights? Well, if we're talking about our z-score, here's what we know so far. I know that the mean is 380, and I know that the standard deviation is 28. So I've got those figured out. What the question is asking me about is what is the value of x? Because x represents the range of weights. Well, I can't figure out x unless I have a z-score. So we got to figure that out. So I need to figure out what is the z value here and what is the z value here. Well, z is based on percentile, which is what percent falls below a certain value. Well, if this is the middle 50%, that means 50% is evenly split into each of these tails. So this means that this is 25% in this tail and 25% in this tail. Well, what percentile is this mark at? Well, it's at the 25th percentile because 25% falls below it. So I need the z-score for the 25th percentile. So that means that I need my z-chart, and I am going to have to work backwards because I don't know what the z-score is. I'm looking for the 25th percentile, so I have to look in the main body of the table for the closest thing to 0.25. And the closest thing to 0.25 lies between here and here, 0.2514, 0.2483. This one is closer to 0.25. So that z-score would be negative 0.67. Negative 0.67. Okay, and then this marks the 75th percentile, because we've got the 50 plus the 25. So look for the closest thing on here to the 75th percentile. And we're looking up here, the closest thing to 0.75. Looks like it's between these two. And this is the one that's closer to 0.75. So that is a z-score of 0.67. Now, makes sense that we would have symmetry here because we're in the middle 50%. So we have the same amount above and the same amount below. So now what I need to do is I need to plug in those z-scores, and I need to figure out what is x. So I need to do it for both of them. The other z-score was positive 0.67. All right, so multiply by 28. And you are going to get negative 18.76. And then you're going to have to add 380. And you're going to get 361.24. That's one value of x. Same thing over here. Multiply by 28. You're going to get positive 18.76. Again, you have to add 380 over to the other side. And when you do that, you'll get 398.76. So to answer the question, this value of x right here is 361.24. This value of x right here is 398.76. And the range of weights is between those. Between 361.24 grams and 398.76 grams. Okay, that would be a good way to write out that answer. Now, here's a bad way to write out the answer. I'll do it in a different color. Don't do this. Don't do 361.24 to 398.76. What does that look like to you? What does that look like to an AP grader? That right there, that looks like subtraction. And we are not subtracting these values. We're stating a range of values. So don't do this. Okay? Again, that looks like subtraction to anyone who is a mathematician. Okay? All right. Next problem. This time we have a sample of 100 Honeycrisp apples, and we want the probability that their mean weight is between 370 and 390. Now, if I write that out in symbols, I'm trying to find the probability that the mean weight is between 370 and 390. That's how it would look in symbols. And technically, I don't need to really worry about if this is or equal to. It's negligible when it comes to percents on a normal curve. So that's not anything to stress out about. Okay, I have 100. I have a sample of 100, so that is going to matter. Okay. Because I have a sample, I'm going to be needing to use those formulas like this. But I am not allowed to use those formulas unless the conditions are just right. So the conditions, again, where that the population needs to be more than 10 times the sample size. So let's check that. 10 times the sample size of 100 is 1,000. Is it safe to assume there are more than 1,000 apples? I would say yes, safe to assume there are more than 1,000 Honeycrisp apples at that orchard, U of M orchard. Okay, the other condition we need to check is the sampling distribution approximately normal. Okay, well, look up in the problem. It says that the weights are normally distributed. So the answer is yes, because the population is normal. All right, so we are good to go to use our formulas. So the mean of the sampling distribution will equal the population mean, which is 380. The sample standard deviation of the sampling distribution will be the population standard deviation, which is 28, divided by the square root of our sample size, which was 100. So our new standard deviation is going to be, I need to calculate this a second here, 28 divided by 10, 2.8. Okay, so now I'm going to need to do some z-score work. So I'll do that down here. I have to do 2 z-scores because I have 2 of these x values. So one, when we're dealing with 370 minus the mean of 380 divided by the standard deviation of 2.8. Get that. And then the other z-score will be 390 minus 380 divided by our standard deviation of 2.8. So type that in your calculator. Our first z-score is going to be negative 3.57 if I round to 2 decimal places. And the other one will be 3.57. Okay, so then up here, I'm going to add on to this that I'm trying to find the probability that my z-score is between those two values, negative 3.57 and positive 3.57. Okay, so we're going to need our z-chart. And we look up the larger value first, 3.57. Okay, now it is off the chart, right? The highest it goes is 3.4. So let's think about this. Think about it in terms of a picture. I will draw a little picture right here. Okay, so typically we go up to 3 standard deviations above and 3 below. Now, if our z-score is at 3.57, that means we're about here. And what we do is we calculate the probability that z is less than that. Well, being less than that is everything. Like that would fill up this entire picture. So that would be a 1 minus, and then we need the probability that z is less than negative 3.57. So negative 3.57 would be here. Being less than that, there's nothing there. So I'm going to get a 1. Now, think about it this way. If I'm between negative 3.57 and positive 3.57, you see how that's everything? 100%. Okay. Next problem is different. I've got 2 examples left. So now this is a whole different problem. You see how there's a percent in here? All right, let's just read through it really quick. So a power company is severely trimmed trees growing near their lines to avoid power failure due to falling limbs and storms. Applying a chemical to slow the growth of trees is cheaper than trimming, but kills some of the trees. Suppose that one such chemical would kill 20% of sycamore trees. That is a proportion. Okay, and that is a population proportion. Keep that in mind. The power company tests a chemical on a random sample of 250 sycamore trees from the population. What's the probability that more than 60 of the trees in the sample die after being treated with the chemical? So we're going to go back to here. If we have a proportion problem, we're going to be using these formulas, especially when we have a sample, and we were told in this problem that our sample was 250 trees. So here's the formulas we're going to use, and again, here are the conditions we have to check. So now going back to the problem, let's check those conditions first. So is the population more than 10 times the sample size? Well, the sample size was 250. 10 times 250 is 2,500. I would say that it is safe to assume that there are more than 2,500 sycamore trees. Okay, then the next thing we need to check is n times p greater than or equal to 10, and is n times 1 minus p greater than or equal to 10? N is the sample size, which is 250. P is the population proportion. Okay, 250 times 0.20, you're going to get 50, and that is greater than 10. And then you're going to do 250 times 1 minus 0.20. And when you do that, you get 200. That's greater than 10. So we're good to go. So here's our formulas we're going to be using. So the mean of my sampling distribution of sample proportions is equal to the population proportion, which we were told is 20%. The standard deviation of my sampling distribution of sample proportions is equal to the square root of p times 1 minus p over n. So in this case, it would be the square root of 0.20 times 1 minus 0.20 divided by my sample size of 250. All that underneath a big square root symbol, and you are going to get 0.025298. All right, so this is the mean and this is the standard deviation that we are going to use in our z-score. Because remember, the whole problem is saying that we want the probability that more than 60 trees in the sample die. Okay, now we are dealing with proportions. Keep that in mind. So think about this. Like when I'm going to go to find a z-score, I'm going to be subtracting this mean and dividing by this standard deviation. Now the common mistake people are going to do is they're going to see, oh, I'm trying to find the probability of more than 60. So they're going to want to plug 60 in here. Now just look at that a second. That doesn't make sense. This number is way far off of these means and standard deviations. So that should tell you something, that doesn't quite seem right. Remember, we're dealing with proportions. So what is the sample proportion here? 60 out of how many in the sample are dying? So the sample was 250. So the proportion of my sample that are dying is 60 divided by 250, which is 0.24. That is what I'm trying to figure out. I'm trying to figure out the probability that my sample proportion of trees that are dying is more than 0.24. So 0.24 is going to go here when I try to find my z-score. So typing all that in your calculator, your z-score turns out to be 1.58. So that means we're looking for the probability that our z-score is greater than 1.58. And remember that when it's greater than, we do 1 minus. So we get our chart out. We're going to look for 1.58, which is right here at 0.9429. And when you subtract that from 1, you get 0.0571. So the final answer to this, the probability that more than 60 of the trees in the sample die, is 5.71%. Okay. So I got one more question for you, one more example. Suppose that in a certain community, 40% of the residents would answer yes to the question, do you know the names of at least 5 other people who live on your block? Suppose you plan to take a random sample of 100 people. Okay, keep that in mind. You have a sample. Also, this right here, this is the population proportion, so that is P. And our sample size is N. So that's the information that you're given. Also keep in mind that this is a proportion problem, so the formulas we're going to use are these guys. And you can see we already have all that information right here. So my mean of my sample proportions is going to be 0.40. The standard deviation will be 0.40 times 1 minus 0.40 over my sample size of 100. When I do that, I am going to get 0.04899. Okay, so keep those in mind for when we need to do some z-score work. We should always check our conditions. I'm just going to do them real quick. Is the population more than 10 times the sample size? Our sample size is 100, so that would be 10 times 100 is 1,000. Is it safe to say that there are 1,000 people in this community? Yeah, I think that would be safe to say. And then we have to check if n times p is greater than 10 and if n times 1 minus p is greater than 10. So if you put those in, 100 times 0.4, because that was p, you're going to get 40. Yep, that works. And then over here, it'll be 100 times 1 minus 0.4, so you're going to get 60, and that works. So everything's good. Now, the ultimate thing we're trying to find is what is the probability that your sample proportion is between 50% and 60%. So in symbols, here's what it would look like. So I'm trying to find the probability my sample proportion is between 50 and 60%. I'm going to need 2 z-scores for that. One when we're dealing with 0.50, subtract my mean of 0.40, divide by our standard deviation of 0.04899. And when you do that, that z-score will end up being 2.04. And then I need to do another z-score for my 0.60. Again, minus the mean divided by the standard deviation. And when we type that in, we're going to get 4.08. So this is, I'm looking for the probability that my z-score lies between 2.04 and 4.08. Okay, now we look up the larger value first, but this is off the charts. Okay, because the highest it goes is 3.4. So this is off the charts. Again, if it goes back to like this problem right here when we were off the charts, if you're shading to the left, it's going to be 100%. Everything will be shaded in. So z being less than 4.08 is 1 minus, and then look up 2.04 on your chart. 2.04 would be 0.9793 right here. Okay, and when you subtract those two, you are going to get 0.0207. So 2.07% is the probability that our sample proportion is between 50% and 60%. Okay, so that was chapter 2 and chapter 7, really in a nutshell, all things z-score probability.